have a project entitled Controlling Devices Remotely Without Manually Switching, which is being submitted for the NI Yantra 2011 competition. The team includes Ashok, Kashyap, Harish and Vesha of BVRIT. And the mentor for the project is Professor Sanjeev Reddy, an Associate Professor BVRIT, and Rohan Sood, Application Engineer NI. The project is implemented using National Instruments WSN. Firstly, coming to the hardware, we have a NI PS15 power supply which delivers voltages between 24 to 28 volts to the Ethernet gateway controller. The gateway controller used is 9792 Ethernet gateway controller, which is connected to the computer using a Ethernet crossover cable. Then we make use of NIWSN 3202 measurement node, which accepts inputs and delivers outputs in a range of 9 to 30 volts. It has 4 analog input channels and 4 digital input-output channels. In order to change the device state and analyze the state, we use a relay circuit which consists of step-down transformer delivering 12 volts to the bridge rectifier circuit, whose output is around 6 volts. Inverter circuits are the inputs of the relay drive separate devices, each of which is connected to its unique DIO port. Coming to the programming part, we need to configure the gateway and the measurement nodes using Max, which is open as shown in the desktop. When the controller is connected via Ethernet crossover cable, the NIWSN software detects the same under the remote devices panel. The nodes in the network can be configured and can be seen. There are 2 nodes. The nodes can be configured, which can be seen. There are 2 nodes which are configured to be connected to the gateway. The nodes in the network can be configured and can be as shown. It consists of NIWSN 3202 measurement node detected, which is a voltage measurement node, and the other node is a NIWSN 3212, which is a thermocouple node. However, the project requires the use of only the measurement node 3202, which is a voltage measurement node, which can be seen. This completes the configuration of the NI measurement nodes. Then moving on to the VI, we have already created a VI. When we click on the VI, a Project Explorer window is popped up as shown in the desktop. In this, here as shown, the device is detected NI and as NI9792 gateway, which is expanded using the plus symbol. Here the nodes which are connected using the configuration settings of in Max. Here we have connected the inputs to the 3202 node, which is a node 2, connected. Then moving on to the project. When the project is open, the front panel is popped up. Clicking onto the show block diagram, we have a block diagram window open. Then the Project Explorer the inputs obtained from the given to the measurement node are dragged and dropped into the block diagram, which can be shown, which can be seen on the block diagram in this way. Here we create an indicator which indicates the whether the supply is connected to the measurement node or not. Then we have a logic less than logic, which shows that here we have a less than logic comparator, which is compared with the one which is a voltage, offset voltage obtained, which is given to the indicator, which glows when the input voltage is less than the 1. When the in the same way, the other device is connected to the other input signal input of the measurement node, which is given to the indicator in the same way, which is programmed in the same way as a measurement node. Then moving on to the digital I/O port, we source the digital I/O pin through the port through the pin 17 of the measurement node 3202. Through that we energize the entire DIO port, DIO pins. Here the DIO pins are dragged and dropped onto the block diagram as shown in the block diagram. Here we create an control such that we can switch the devices such that here gives the signal strength with which the measurement node is connected to the gateway. Then moving on to the front panel of the project, here the front panel consists of a analog input, which is a active high when there is no input, and the analog input 1, which is from the device 2. This indicate whether the device is on or off. The Boolean LEDs here indicate the status of the devices. Then running the program deploys the program onto the hardware. Then closing it. When we switch on the digital I/O port, then the relay is switched on and the bulb gets blown. Then switching the digital I/O switches on the device 2. Then in the same way we can off the devices by just clicking on them. This concludes the process.